Hey guys, my name is Mark Min Kim. Today we're going to talk about type safety with GraphQL. If you guys have worked with GraphQL before, in TypeScript specifically, this may be a little bit basic, but for those who have not, this can be a really interesting introduction to TypeScript generation. About myself, I was made in Korea, South Korea, not North. Enjoying freedom in Canada. I moved to Canada when I was 19. Ever since then, I've been enjoying my freedom. I enjoy traveling and making new friends over food, especially ramen. I love ramen, cooking ramen as well, and beer. I'm passionate about GraphQL, hence I'm talking about GraphQL. I'm currently working at Kong for insomnia. Thanks for Dimitri for having removed a lot of TypeScript tech debts. Yeah, let's dive into it. What is this talk about? It's not about why we should use GraphQL, but how it helps ensure type safety. So I'm not trying to sell GraphQL to the audience here. And we will go over what is GraphQL and how is GraphQL different, and comparison in TypeScript in terms of how it's implemented with REST API versus GraphQL. And we're going to talk about, what if kind of situation, and then summary. That's the kind of agenda of this talk. Another thing is that my English is not first language, so if I make some unclear expression, then please understand my English is not perfect. Yeah, let's talk about what is GraphQL. It is a query language, an execution engine to describe the capabilities and requirements of data model for client-server application. This is like basically straight copy-paste from specification. Behind the scene, how it's implemented, it varies by different languages, but it all follows the same spec. So we're gonna quickly go over how it's implemented in JavaScript. So this is actually a GraphQL JS repo. Any kind of GraphQL client in JavaScript uses this library. So basically, this is the function that's exposed, and it takes a bunch of argument, and the first thing it does is to validate against the schema. So it passes the schema and validate. If there's no error, then goes next and parse the source, which is the GraphQL, the actual query, and then if the parse is successful, then validate that parsed document against the schema, and then execute it. So this is a set of the flow that's defined by the specs. And then in the execution phase, you're going to build a context, and then after you build a context, if there's no error, then we're gonna execute the actual implementation. This is where you check the operation type. You know, is it query? Is it mutation? Is it subscription? And then you're gonna execute the resolver, and then build a response and return it to the where it's called. This is basically how the GraphQL is implemented in JavaScript. How is GraphQL different from REST API? It's hierarchical. So what do you mean by hierarchical? So let's take a look at the example of mock API. So note that this is the introspection, and the root is the query. And when you go into the root query, there's the different fields. And each field has the type definition. And you can dig into next one, the next one, next one. So this is the hierarchical structure. So that's what I mean by hierarchical. And product-centric. So compared to REST endpoints, this is very dependent. This is very dependent on the product use case. So instead of we have a data model A that's exposed to REST endpoint, this needs to be designed for a use case. What do I mean by that is there's a product page A which has the several different data type. One query or mutation can be in one request, and it can query different models instead of exposed by several different endpoints. So that's what I mean by what I mean by product-centric. And strong typing. So as we saw in GraphQL JS package, it does several validations before you actually execute it. So because of this validation, it's very strongly typed. And client-specified queries. Compared to a REST endpoint that gives you all the fields that's defined in the endpoint, you can specify what fields that you want to be used in the front end. So if the mobile only requires 3 fields, you can just pass the 3 fields and you just retrieve those 3 fields. If a web application requires 4 fields, you can still send the same query with 4 fields and you retrieve only 4 fields. Whereas the REST API, it gives you everything that's defined in the endpoint. So take everything or don't take it. Whereas the GraphQL is you can specify what you want to retrieve. It is also introspective. What it means by that is that it gives you an interface that you can check what are the definition of the schema. So this is an example of introspection. You can check the types. You can query the introspection schema so you can see what the schema definition is without interacting with the GraphQL in code. So that's how GraphQL is different from REST API. Now let's dive into a comparison in TypeScript. We're going to take a look at the Rick and Morty mock API. This is the implementation with REST API. There's a really good documentation about this API, and it's implemented in both GraphQL and REST. So I thought this was a good idea to use it as a mock API and build something out of it. Yeah, so basically this is a React application with TypeScript. This app component has header and the search bar, and then character list. So as you saw in this UI, there's a app bar and then character list, and this is like a grid that iterate each item and just render the card. So it's a very simple application, and this is implemented with the React query. So it makes the instance of query client and pass it through query client provider. So the below DOM tree can access the client. So now here, when we look at the character list, we have pagination stack and then grid. And this is where it's iterating. But note that we have type any here. Why is that? Because we have no idea what the endpoint is going to return. We can check what it's going to return on the API level, API documentation level, so you can actually, hit the endpoint through a HTTP client like, Insomnia, and then see what's returned. So you can just guess the type and type it, right? So, for instance, this one, let me result. Yeah, you're gonna have ID, which is number, name, which is string, status string. Probably this is gonna be enum. Species, humanoid. This is probably gonna be string enum, type. So you have to actually manually type these things, unless you use some really complicated type generation with OpenAPI spec. It's pretty manual process, right? But if you use GraphQL, you can generate the types on the fly by running some command line. So we're going to convert this code base into GraphQL. So the first thing we're going to do is we're going to create codegen YAML file. So this is going to be using codegen from the Guild. They have a lot of different plugins that allows you to do any other utility functionality into the GraphQL. So we're going to use a couple of plugins to do this. In this config file, schema means that it's going to look at the introspection schema, and then it will pull the introspection schema to generate object, and then we're gonna pass it to a plugin code that we're gonna look at in a bit, and then it will look at all the GraphQL document, .GraphQL files to gather all the documents, and then we're gonna parse it, and we're gonna validate, and then we're gonna generate the TypeScript. So yeah, this is the equivalent to the endpoint that we were looking at. This endpoint. Equivalent to this one is characters query. So we're basically defining in .GraphQL file that we're gonna operate query operation with operation name get character list, and we're going to query the characters with info and results. And results will query the fragment, which is partial of character entity. So now when we run npm run generates, which is basically calling GraphQL codegen package with the CLI that you install. It's going to parse through those GraphQL file and then generate the file. So now it's generated the output. When we look at the output, voila, there's a GraphQL TypeScript that's defining the GraphQL types. So you can now use this to type your front-end code instead of having to look at the actual REST endpoint and then manually type the definition of it. So instead of any, you can just use the get character list query, which defines what is the variable of this query and what is going to be the return type of the query, and you can just use that where it's used. I'm going to just revert this one. Yep, sure.
So this is generating from your GraphQL schema to be used in the front end. Right. But like you pointed out earlier, a GraphQL schema can sit in front of multiple REST APIs. Is there a way to avoid like a duplication of schema from those open API specs of the REST APIs to GraphQL? Like take this generation like one step back into the APIs too?
Yeah, so you can do the exact same thing in your Express server or whatever, GraphQL server. You would have to define each, let's say if this GraphQL server is gateway to different microservices, then each microservice also needs to provide schema. So essentially you have to build the super graph. Then you can make sure that everything is typed. But most cases you are not, you don't have GraphQL from the get-go, right? A lot of you guys probably have REST API, and then you may want to transition from one gateway that talks to REST API, and then if you have time and resource, then you're gonna transition from REST API to Graph API, like one by one, right? So essentially you will query entire fields, and then in the gateway service, you're gonna have to filter out what fields to be returned, right? So that type generation happens in the gateway server. Basically, yeah, that's how it will work. Yeah. Yeah. Cool. Okay. So now when we run start, it'll basically return the same thing, but everything is typed now automatically. You don't have to check it manually by hitting the endpoint. So that's pretty much the comparison in TypeScript. And now let's take a look at how it generates the TypeScript file. So when we look at this plugin package from codegen, at this particular unit test, so it's taking the GraphQL document to build a schema, right? And then it will pass it to a plugin, which is the the plugin code that they provide. It's going to convert this into a node, and it's going to visit each node to see what type of the document is. Is it enum? Is it a class? And then it's going to pass it to a builder object, and they will just generate the TypeScript file. So that's how it's generated. Yeah. So, oh wait, what if the data transfer object changes from the server? So let's say one particular endpoint changes the field name from XYZ to ABC. How do we make sure the typing is safe and valid? Well, you don't really need to worry about this, because if you pipe this up in the CI/CD, and if this type change is reflected on introspection schema, then you can still pull the latest introspection schema and generate the type, and it will validate. So let's give a quick run here. So let's say in this .graphql file, it used to be, let's say, ABC. The field that you are querying was ABC, but now your backend changed to next. So when you have not most recent GraphQL file in the front end, and you run type generation, it will fail, because this field name doesn't exist in the introspection schema. So if you pipe this up in your CI/CD pipeline, you will always have up-to-date schema. So you will always have type safety. I mean, always is a strong word, but yeah, this way you can validate schema each time you run the PR, or each time you build something. Even the development time, you can make sure that you're pulling the latest introspection and validate it. Oh, this is invalid. Then you will have to either talk to the person who made the change, or just fix the TypeScript. And then you make a PR. And then in the PR, it also runs the CI/CD. And by the time you merge the code, it's already type safe. The summary of it is that GraphQL offers a very strongly typed schema definition. And it may not be for every use case, but if you use it for the right use case, it can save you a lot of time, because you can write the query as if it's used in the production, like how it's used in the product page, instead of having to pull all the fields from the REST API and then just choose whatever you need to choose in the code. You can just define that in the GraphQL, and you can stop manually typing interfaces and types, and you can catch breaking changes before going to the prod. So yeah, GraphQL offers type safety. If you have any question, please feel free to ask. Yeah.
Thanks for the talk. I would like to ask, so what are the use cases where it's not advised to use it actually, or where it can be problematic?
For GraphQL?
Yeah.
If you don't implement the GraphQL right, it can be a performance issue, performance bottleneck. Yeah. So that's one thing. I think you should probably look at the return of investment, right? So if you only have a one client application and you want to go crazy with GraphQL, it's probably not worth the time. But if you have several different applications, or if you have a micro front-end architecture, you probably want to make sure that all the type interfaces in each application is the same. So you want to make single source of truth for the type, right? So in this case, it may be very useful. But if you don't have complicated architecture, maybe it's over-engineering. Yeah.
And like without codegen, there's like duplication of it. If I have like my GraphQL schema is like hitting a REST API and I want to like add a field to it, I have to add it in like 2 spots. If you don't like codegen it, which can be, extra work too.
like really, I think the use case that you may want to implement the GraphQL is when you want to have a single source of truth for interfaces. I mean, it probably applies to many cases. Yeah. Anyone else have a question? Yeah.
As an API developer, would you ever want to, I guess, publish predefined types for your consumers? So you could use this to generate types based on whatever schema you've already defined and then allow your consumers to use that library or those types within their TypeScript project? Or would you assume that this would be used kind of independently, like each person could implement it on their own?
But the way GraphQL works is that you would publish that schema through the introspection, right? And yeah, so you would have to publish that interface, but you may publish it privately. So people who are not using, applications who are not using your GraphQL cannot really know what are the interfaces, what are the fields that's available. You may use it for internal development purpose, unless this GraphQL interface is for public use. Like for example, like Shopify has a public use because they need to allow developers to integrate, right? So yeah, so you would publish, yeah. And you can still do it with REST way. You can publish the Open API, but making it consistent, it's a challenge for Open API, right? So yeah.
So do you need to have the introspection API published? Are there people out there that have GraphQL publicly accessible services but turn off the introspection stuff? Does that make sense? Or is it required?
Well, I would assume that this introspection publication, like accessing to the published introspection, would probably filter by their network layer. So if you're not, signed into their VPN, then you probably would not.
In other words, like you don't have to have the introspection access to do GraphQL, to write GraphQL queries and send them. Yeah. Okay.
No, you don't need to. Yeah. Yeah. And if you want, you can probably have monorepo that has Express server or Node.js server that you can generate the GraphQL schema and then use that to generate the types.
Oh, okay.
Yeah.
Cool. Huh.
It's probably easier with a monorepo because if you're publishing on a private registry, then you have to have Dependabot, let you know all the other services that have to update to get the latest to that package. And if it's just a monorepo, it's all there.
So the publishing does not mean you're publishing npm package.
Oh.
Publishing means you are publishing the introspection schema. So you can go to a certain URL and see all the documents.
Okay.
So that's what I mean by publishing it. I guess it may be a little confusing to publishing the types as the npm package, but you can just do this locally and then commit that generate type file so you can validate, okay, there's something changed or not, right? Yeah. Anyone else?
Great. Thanks, Mark.
Thank you.